Hey guys, so today we're going to start officially talking about proportions. We talked about them a little bit yesterday, but today we're going to only focus on proportions. So proportion is related to ratios. A ratio, if you remember from yesterday, is two quantities. If we compare them, it's a ratio. Now, if I have one ratio and I have another ratio, and they're equal, then they're called proportions. Some familiar proportionate ratios that you are aware of from your math academic career here at school would be equivalent fractions. Equivalent fractions are two ratios that are equal. So with that in mind, that's going to help us also in determining if something is proportional, or if something is proportional, you can discover information from that. So let's go ahead and move on with this. It says a proportion, which again, please have your notes out. Have a pen or pencil in hand and engage in what's going on. You will remember more if you do. Plus, you can refer back to these at any point. So it says, is just two ratios that are equal to each other. You can tell if a proportion is truly a proportion by cross multiplying and seeing if it's equal. So if you're in a situation and you're like, are they proportionate? Let me show you a way to determine that, to say yes they are or no they are not. So here are two ratios. And so what I'm going to do is I'm going to do cross products. We did that a little bit yesterday. 4 times 10 is 40. 8 times 5 is 40. And so, yes, this is considered proportionate because 40 equals 40. Then let's do another one. 5 times 12 is 60. 35 times 2 is 70. And these are not equal. So no, those two, they're ratios, but they are not proportionate. We can't just assume they're proportionate. Now, the next problems are all going to be proportions. We are going to use what we know about proportions to find information. So it says you will multiply diagonally, then you will solve the equation, set up as an equation, and then solve the equation. So let's get at it. 11, well, let's go ahead and do 2 times x. Now I'm going to be intentional and try to keep my variable on the left-hand side. 11 times 12 is 132. Okay, so now I have an equation, a one-step equation, which is what we've already had in a test over that. Hope you remember how to do it. So I'm going to divide both sides by 2 to solve for x. Divide by 2, divide by 2. X equals 66. And so that is the missing number. Let's do the next one. 9 times 8, 3 times x. I'm going to try to be intentional about keeping that variable on the left-hand side. Now I'm going to divide both sides by 3. X equals 24. And I already had that worked out on a scratch piece of paper, so I'm not that smart figuring it out that smart. But go ahead and catch yourself up. The process is the same. Again, this would be top in the box is where I got the 24. Or on this one, 132, top in the box is where I got the 66. Top in the box. Next one. 2 times x, I'm going to go ahead and keep the variable on the left. 5 times 3 is 15. I'm going to slow this one down a bit, and you'll see why in just a moment. So we have top in the box. And of course, this is a time that if you wanted to pause and work ahead and then see if you got the right answer, that would be an awesome idea. So feel free to pause right now if you'd like. All right. 2 goes into 0, 1 0 times. It goes into 15 7 times. Add a decimal, bring it up. Add a 0, bring it down. 2 times 5 So x has a decimal in it. That happens, and that's okay. Let's do another one. 5 times x, keeping the variable on the left-hand side. 6 times 15 is 90. To solve, I divide both sides by 5. Feel free to pause right now and see if you can't figure out what 90 divided by 5 is. 90 divided by 5. 1. Bring down the 0. 8. And I'm done. No decimal in that one. Now, I'm going to go ahead and circle all my answers. All right, now sometimes you can cheat. It's not really cheating. It's just knowing numbers, knowing your times tables enough to where you don't even have to cross multiply and divide. This works out quite often, so let's check it out. I'm going to come on down to these last two, and I'm going to look at these. I have a 2 and an x. I don't know what x is. But if I look at the 5 and the 35, I don't know. When I see 5 and 35, I think times 7, because 5 times 7 is 35. Now, this is when we go back to equivalent fractions. Remember when you had to create an equivalent fraction? Whatever you multiply the denominator by, you have to multiply the numerator by. Well, 5 times 7 is 35. What is 2 times 7? That's right, 14. So instead of cross multiplying and dividing, I was able to just create another equivalent fraction. It's the same thing. Equivalent fractions are proportions. Let's look at the next one. 6 and x, there's nothing I can know about that. But if I look at the 5 and the 15, what 5 is 15 a multiple of 5? It sure is, because 5 times 3 is 15. So what is 6 times 3? 6 times 3 is 18. So I know that x, that missing value, is 18. Pretty cool. Look for that before you do all the cross multiplying and dividing. You might save yourself some time, but if you cross multiply and divide, you will get the same exact answer. Good luck. Ask questions if you need any help, and I'll see you later. Bye-bye.